In this video, we will look at solving systems by linear combination. By the end of this video, you should be able to solve a system of linear equations in two variables algebraically using the linear combination or elimination method and solve real-world problems involving linear systems. So let's take a look at what all that means. In our previous lesson, we looked at solving algebraically using the substitution process. In this process, we had equations that had x equals or y equals, and we substituted or replaced that expression into the other one. Looking at my two equations here, I don't have that, but I know that I can easily solve for y. So let me take my first equation and try to solve for y. So I have 2x plus 3y is equal to 11. If I want to solve for y, I want to subtract 2x from both sides. I'm left with 3y is equal to negative 2x plus 11. Divide each term by 3. And I see I have y equals negative 2 over 3x plus 11 over 3. Now if I look at this, my next step would then be to substitute back in for y, which I can do. It is an option. However, looking at my fractions here, that may be a challenging thing to do. So it might be easier to try a different method called linear combination. So in this method, we look at our steps. This one says step 1, write both equations in standard form. If we look at our two equations that were given, they are both in standard form, making this method a little bit easier to tackle. So our second step is to make sure the equations have one variable with opposite coefficients. So if I look at the given equation here, I do have opposite coefficients. I see that I have plus 3y and a minus 3y. So this makes us a good fit to solve by linear combination. So I'm going to go ahead and rewrite my equations over here. 2x plus 3y is equal to 11. And then I have 3x minus 3y is equal to 9. So when I look at these two, by linear combination, I have plus 3y and minus 3y. I'm going to do just that. I'm going to combine the two equations together. I'm going to draw this line here and combine them. So I'm going to basically add up and down each term. I'm going to combine like terms. So I'm going to have 2x plus 3x. I'm going to get 5x. Here, when I do plus 3y minus 3y, they will cancel out. I get 0y is equal to, when I add here, 11 plus 9 gives me 20. Okay. I can rewrite this. 0y can cancel out. 5x plus 0y is just 5x. That's my identity property. 5x equals 20. I can divide both sides by 5. So x is equal to 4. Okay. So I've added the equations, I combined them to make one equation, and I solved the one variable equation. I got x equals 4. Now if we remember, our solution needs to be in the form x, y. I don't have that just yet. I have the x. I need the y. So now I'm going to go back just like I did in substitution and plug it into my equation. So here I have 2. Instead of x, I'm going to put my 4 plus 3y is equal to 11. So when I solve this, 2 times 4 is 8, plus 3y is equal to 11. If I subtract 8 from both sides, I get 3y is equal to 11 minus 8 is 3. Divide both sides by 3, y is equal to 1. So my solution is the point 4, 1. And that is how we do our linear combination method. We use this value to solve for the other variable, and we can check our solution in both equations. Let's take a look at another example. In example 2, again, we're given the directions, solve the linear system by linear combination. So here again, both of my equations are in standard form. That's my clue that elimination is going to be my best bet. Okay, so they're both in standard form. That meets the criteria for our steps. Make sure the equations have one variable with opposite coefficients. That part, when I look here, I'm close. I see I have a 5x and a 5x. They have the same coefficients. So I can make my equations be opposite by multiplying each term by -1. This way my positive 5x will become a negative 5x. But that means that each term needs to change as well. So my positive 2y will become negative 2y, and my positive 11 will become negative 11. My second equation remains the same. 5x minus 3y is equal to 21. So that when I start to combine, again, I'm adding up and down. Negative 5x plus 5x gives me 0x. That's my inverse property. Negative 2y minus 3y gives me negative 5y. And negative 11 plus 21 is going to give me 10. My 0x will go away. I have negative 5y is equal to 10. Divide both sides by negative 5. Y is equal to negative 2. Again, I need my answer to be an x, y. So I now have my y portion of the solution. I need my x. So I'm going to take this and plug it into this equation. So I have 5x plus 2, and instead of y, I'm going to substitute in my negative 2 is equal to 11. Notice that I went back to my original equation, not the one I multiplied. I went back to my original equation. So now here I've got 5x, 2 times 2, I've got negative 4 equals 11. 2 times negative 2 gives me a negative 4. I add 4 to both sides. I get 5x. My negative 4 and positive 4 cancel, equals 15. X is equal to 3. So my solution is 3, negative 2. My x value is 3. We will continue to work on more examples in class. Please make sure you bring your notes with you so that we can work on them and continue to practice linear combination together.